Hey everyone, welcome back to the channel. In today's video, we are going to dive deep into batch normalization in neural networks and especially how to implement it in Keras. We'll explain the theory behind it and its benefit and then walk through a step-by-step code implementation. We'll also add the complete the visualization to help you understand it better. So by the end of the video, you have a solid understanding of why and how batch normalization improves the training of a deep learning models. So let's get started. So little bit of theory behind the batch normalization. When we train a deep neural network, one common issue is the vanishing or exploding gradient problem. This happens because the value of a weight and activation can become too large or too small, and especially as the network gets deeper. This slow down and even prevent the network from converging properly. So batch normalization helps mitigate this problem by normalizing the activation of each layer in the network. Essentially, it standardizes the input of each layer so that activation have a mean of 0 and the standard deviation of 1. So here's how the batch normalization works. First, it's compute the mean and the variance of each features in the mini batch. Second, normalize the activation by subtracting the mean and divide by the standard deviation. Third, scale and shift the normal activation using learned parameters called the gamma and beta. So these allow the model to recover the representation power if needed. And this process allow the network to train faster and often lead to better performance. You can see how for the batch normalization, the networks converge much faster and the training process is more stable. So now that we understood the theory, let's take a look how we can implement this with the code. So here I'm importing the libraries, which is required the Keras, the sequential API, the batch normalization, and the for optimization add up. Next, we are creating a simple sequential model. So we are adding the, as you can see, we have built a simple straightforward feed-forward neural networks. Notice we have added the batch normalization at each step after a dense layer just before the activation function right here. We run this. In the case, adding a batch normalization is simple as like adding a batch function layer. It does not require much tuning. So Keras handles the computation of the mean, variance, and scaling the parameter automatically. So now let's briefly go over what happens when we train the model in the train the model. So batch normalization layer. So this layer works by taking the input activation of each batch and normalizing them using the statistic of the batch. So during inference or testing, Keras uses the running average of these statistics. And to understand the batch normalization, let's visualize some plot of file generating simple example. So let me run this. Let's compile the model and let's see the summary of the model. And let's to understand the effect of the batch normalization, what I will do, I will create two models, one with the batch normalization and another without batch normalization, and we'll visualize with some plots. So for this, let's generate some simple example where we compare the activation of the layer with and without batch normalization. So we'll use some random data set to illustrate this. So for this, let me load some of more additionals libraries. So we are going to do classification Let me create the data set. So here we are using 1000 samples with 20 features. And I've already split the data into for training and testing. And let's build the model first without the normalization. As you can see, there is no batch normalization here. So let me run this. And let's compile and run the model. This is done. And in this, as you can see, I've added the batch normalization here. Do the same thing. And now let's visualize how the batch normalization affect the training process by plotting the loss curve. So I'm just simply plotting the loss curve. As you can see in the plot, the model with the batch normalization tend to have a smoother and the faster converge. And this is because the normalizing the input helps prevent issue like vanishing the gradient. So before we wrap up, let's go over some of the advanced tips and points regarding the batch normalization. The first one is when to use batch normalization. You should generally use batch normalization in the deeper networks where training instability is more common. It is not always needed in shallow network or a small data set. Second one, batch normalization at test time. So at inference time, batch normalization uses the running average of the mean and the variance calculated during training. So this makes it a little different from the training phase. Third, the dropout versus batch normalization. So as you know, batch normalization can reduce the need for dropout because it stabilizes the learning process and reduce overfitting. And the last one, the training with small batches. So batch normalization tend to work best with the larger batch size, as smaller batches can lead to noisy estimate of means and variance. And that's wrap. So we have covered everything from the theory behind the batch normalization to how you can implement it in Keras. And if you have any questions, feel free to leave them in the comments below. Thank you for watching. I will see you in the next video.